Assalamualaikum warahmatullahi taala wabarakatuh. My name is Fahmi Ariffin. My matrix number is 22111092. I am from class 1 TSI and today I will be sharing about network analysis by me and Ridhwan Hakim. So first, we're going to talk about OSI model, the OSI 7 layers. There is 7 layers of it, and we'll start with application layer, which is the example protocols is HTTP, presentation layer, SSL, session layer, PPTP, transport layer, TCP, network layer, IP, data link layer, PPP, ATM, Ethernet, and physical layer, which is Ethernet, USB, Bluetooth, and IEEE 802.11. How OSI model works? In application layer, the parts of the network stack that communicates with the application. These include networks APIs. The presentation layer. This layer translates the data between the application and the network. Session layer builds and maintains a session between application process. Transport layer takes a stream of data and breaks it into segments. This allows multiplexing on the network, allowing more than one traffic flow at once. Network layer provides addressing and routing service. And data link layer handles delivery of data between two nodes connected to a physical medium. And lastly, physical layer transmit and receive data across a physical medium. This may be electrical, light, or radio signal. Next, data flow. When an application needs to access the network, it starts at layer 7. Data is passed down through the layers to layer 1, which is layer performing necessary functions. When data is received by a host, it is received at layer 1 and works its way back up to layer 7, where the application is waiting. When information is moving down the layers, some layers will encapsulate the data. Encapsulation is the process of adding more and more information. As an example of this is at layer 3, where a destination IP address is usually added. Adding extra information like this aids in the delivery and handling of the original data. Picture a piece of data as a block of ones and zeros. During encapsulation, more data may be added to the front or back of this block. Data to the front is called a header, while data added to the end is called a trailer. When information is received by a host, the process is reversed. Headers and trailers are removed and the data moves back up the layers until eventually the original information is left for the application to use. Okay, this is the sequence. It starts with the application layer, presentation, session, transport, network, data link, and physical. All these are the examples of each layers. IP and MAC address, MAC address. So the difference between IP address and MAC address is IP address stands for Internet Protocol, while MAC stands for Media Access Control. IP address is logical address. MAC address, it is a physical address. IP address, it is provided by the Internet Service Provider, ISP, while MAC address is provided by computer manufacturer. IP address, it can be changed by ISP. MAC address is fixed address for a particular device. It cannot be changed. IP address, it has various classes like A, B, C, D, E. And MAC address, it has no class concept. IP address, it is applicable on network layer of OSI model, and it is applicable on data link layer of OSI model. IP address, the length of IPv4 is 32 bits, and the length of IPv6 is 128 bits. For MAC address, the length of the MAC address is only 48 bits. Next, packet forwarding. So packet forwarding is the process of a network component accepting a packet and transmitting it to a destination. For example, a router receives packet from host one on attached network and forwards them to host on another attached network or another router for further forwarding, packet forwarding. So this is the example of packet forwarding. This is from a device to a network switch, and lastly to expeditor, and expeditor move it to DSL cable modem, which is physical and to the internet. Okay, so for example from command prompt, from my device to Shopee HQ in Singapore. So this is all the IP address that through that the data has been through to Shopee HQ.
Assalamualaikum. Saya Ridhwan Hakim dari Jafar 2210309. Partner dengan Fahmi. So saya akan cakap pasal error control related. Error control is the process of detecting and correcting both the bit level and packet level error. There are two types of error. There are single bit error and burst error. Single bit error when there is a change in only one bit of the ATA, then it is called a single error bit. For burst error, when there is a change in two or more bits of the sender data, then it is called the burst error. Next, the handshake protocol involved. The handshake process set up automated parameter for communication between devices before normal communication begins. Much like the way a human handshake set the stage for the communication to follow, the computer handshake provides device with rule for the way data is to be shared between them. Second, the next one is TCP or IP. TCP or IP stand for Transmission Control Protocol or Internet Protocol, and it is a suite of communication protocol used to interconnect network device on the internet. There are 4 layers of TCP or IP model. The first one is application layers, then transport layers, network layers, and physical layers. Next is UDP. UDP stands for User Data Protocol. It is a communication protocol that is primarily used to establish low latency and loss tolerating connection between applications on the internet. UDP speed up transmission by enabling the transfer of data before an agreement is provided by the receiving party. Next one is routing. Network routing is the process of selecting a path across one or more networks. The principle of routing can apply to any type of network, from telephone network to public transportation. Next one is subnet. A subnet or subnetwork is a network inside a network. Subnets make network more efficient. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary router to reach its destination. So here is network. Inside the network has subnet. The next is how the data travel in a binary. Current and voltage are inseparable. The current is flowing because there is a voltage on the wire, and there is conductive path from the voltage to a lower voltage. The voltage at the location on the wire is just a simpler way of looking at the fact that there is an electric field between the wire and everything around it. When a signal propagates along a wire, it's actually the electromagnetic field between the wire and nearby ground or return conductor that is propagating. So it is actually an EM wave, not a massive object like an electron that is carrying the signal along the wire. Last one is network topology. Network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. There are two approaches to network topology. It is physical and logical.
Okay, so for the message we want to send to University Malaysia Sabah. So first thing first, we will configure what is the IP address of the server of University Malaysia Sabah. So we have done it earlier, and this is the IP address of University Malaysia Sabah 103.26.197.21. So this is the IP address. So for my device in UPLM to University Malaysia Sabah, there is 30 hops for the packet to arrive to University Malaysia Sabah. That's all for us. Thank you very much.